Most of us know that a spark plug is used to create the spark that ignites fuel in an engine, and for many people, that's all it's ever meant to do. But I'm sure you've never seen a mini welding machine made from a spark plug before. In this video I'll turn a spark plug into a mini welder, so let's get started. And in the first step, I'll remove the connector tip and the inner core of the spark plug, so it's easier to work with in the later assembly steps. Since the copper conductive core inside the spark plug is difficult to remove by hand, I'll use a bench vise and a pair of pliers to make the job easier. So now, the copper conductive core inside the spark plug has been completely removed. It takes a bit of effort, but honestly it doesn't take much time to get it done. What's left is just a hollow spark plug. While researching simple DIY solutions, I came across a very insightful article on Instructables. The article explained that the carbon rod inside an AA battery can be repurposed as a DIY soldering tip for low-power soldering tools. It may sound unusual at first, but from a technical standpoint it makes a lot of sense. At its core, the carbon rod inside an AA battery is a solid graphite element with stable electrical conductivity and high heat resistance. When electric current flows through it, carbon generates heat efficiently without melting or deforming like thin metal tips. This allows it to reach solid melting temperatures while maintaining a controlled and focused heat zone, exactly what small soldering tools require. Another key point is material safety. Carbon is an inert, non-toxic material and can be safely handled by hand during fabrication. That said, since the rod comes from a used battery, it's still important to wash your hands thoroughly afterward to maintain cleanliness and avoid contaminating food or everyday items. Turning the carbon core from an AA battery into a DIY soldering tip isn't particularly difficult. The real challenge is applying just the right amount of force, enough to shape it but not so much that the carbon crumbles. Get that balance right and you've got a successful result. And to connect the spark plug to the battery, you should prioritize using flexible stranded wire, made up of many small strands twisted together, which handles current well and is easier to work with. During testing, if the wire isn't secured to the spark plug body, it tends to get in the way. So I'll tape it along the length of the spark plug using electrical tape to keep everything neat and stable. At the other end of the wire, to connect it to the power source for the welding setup, I'll attach an alligator clip for a quick and secure connection. This is the alligator clip I mentioned earlier. It allows for quick and simple connections to the power source without complicated setup, which is especially useful during testing. With a strong grip and reliable electrical contact, it ensures stable current flow and can be easily removed whenever adjustments are needed. We're not done just yet. Next, we'll make another connector for the negative terminal of the power source. Its construction is very simple, just a length of wire with 2 alligator clips attached at both ends. Once this part is finished, I'll move on to assembling the entire setup completely. The power source for this mini welding setup is a small battery, compact and convenient. It provides just the right amount of power, making it suitable for both testing and practical use. When the 2 terminals of the power source come into contact, we can see an electric arc forming. That's a clear sign that the device is working as intended, which means we've succeeded. I'll run a few small tests, just enough for you to clearly judge how effective this setup really is. So make sure to watch the video all the way to the end. Right from the very first test, it's clear that the heat is distributed evenly without causing aggressive. This is definitely a strong advantage of this DIY welding setup. In the second test, this DIY welding device easily joins 2 small metal pieces together without causing any major damage, only a slight deformation at the weld point. Pretty useful, wouldn't you say? And for the third test, we'll try welding razor blades together, which is easily the most challenging test of them all. Let's see whether this DIY welding device can actually pull it off. And with that, the toughest test comes to a successful close. From small metal parts to thin razor blades, this DIY welding device has proven its stability, heat control, and real-world usefulness. It may not be perfect, and it's not meant to replace professional equipment, but based on what we've seen, it's clearly a practical and effective DIY solution. And for me, that's more than enough to call this experiment a success.